Hello. The last part of this chapter is to derive the misspecification bias in an over-identified case. So the question is like this. Now we have, as before, we have two variables, and we know, and as before, x1 is exogenous, correctly exogenous, and we know that. So it's fine. But x2 is an endogenous variable, and we know that. Okay, that's nice. And we have two instruments. We only need one. One is sufficient, but somehow we find two instruments, so we are going to use two instruments. In general, as long as two instruments are correctly specified, they are exogenous, then using additional instrument will be better. It provides more variation than you can utilize in analysis, so your estimator will be more accurate. So it is almost always nice. However, the problem here is you added an additional instrument, but unfortunately that was a wrong instrument. So you wanted to improve your estimator by including an instrument, but the additional instrument was not correct. So Z2 is fine. Z2 is a correct instrument. So if you have not used Z3, then everything is totally fine. But what is the effect of including an additional instrument? But actually it was wrong. It's interesting, but now we are going to think about a fitted value approach, because now we have to handle three variables. So 3 by 2 matrix is not easy to handle as before. So 2 by 2 is maybe the maximum we can handle the inverse of the matrix. So we are not considering the matrix approach, but we will take this fitted value approach. So x2, the endogenous variable, can be written as gamma 1, x1, gamma 2, x2, gamma 3, z3, gamma 2, z2, gamma 3, z3 plus xi. So all the exogenous variables are included, but actually there is a spy. Z3 is not an exogenous variable. By the way, xi does not matter. Z is always uncorrelated with xi because, as you remember, when you define this equation by linear projection, so then by construction, xi is always orthogonal to all the regressors. So it is not a problem, but the problem is correlation between this guy and this guy. Of course, epsilon is also correlated with this one, but this is the main problem. Then remember, we took the fitted value. x2 is the fitted value, and it can be written as this way. So we drop the xi, which is potentially correlated with epsilon. So we remove the correlated variation in x2, and we only use x hat, the fitted value, which by construction must be uncorrelated with epsilon, but in our case, because of the misspecification, now this is correlated with epsilon because this part is correlated with epsilon. That's the problem. And remember, we have to plug in x hat, the fitted value, in the place of original variable x2. So replace x2. x2 can be written this way, and then rewrite this, and we get this. So x2 is replaced by x2 hat, and epsilon is replaced by ui, because ui, the extended error term, has to take care of xi at the same time. So then what we needed was, we had to show that x2 hat is uncorrelated with u. That was true. That holds when Z3 was exogenous, but now it isn't. So if you recalculate if you calculate the covariance between x2 at the fitted value and the extended error term, and then everything x1, x2 are not correlated, so they disappears, and only z3 is correlated with epsilon. So as a result, you get gamma 3 rho. So then that is the, so then if, as you can see, this is an endogenous variable. So because this is endogenous, it is, its bias affects beta 1. Beta 1 is also biased. Now it equals to the misspecified exogeneity example. So beta 1 is biased. Of course, beta 2 is biased because x hat is endogenous. And now, if you want to derive the misspecification bias, I will take this form. Now it is 2 by 2 matrix, so 2 regressors case. So you can handle this two variable inverse, blah blah blah. Then do the same thing as we did before. And here, rho was replaced by gamma 3 rho. Gamma 3 rho is given by this. Then what can we tell? You can use the same intuitions we had before. First, beta 2 is biased, which is obvious. But also, beta 1 is biased. That's like consistent throughout the misspecification analysis. And for beta 1 to be uncorrelated, one of these three must be 0. So if rho is 0, that means all the instruments satisfy the exogeneity assumption, which is obvious. Then we are not going to have any bias. And gamma 3 is 0. That means gamma 3 is 0, this is 0, this is 0. So if the wrong instrument is uncorrelated with x2, that's nice. Then it does not cause any problem. However, so it's interesting. So that means z3 violates the relevance condition, which actually helps. If exogeneity condition is violated, you want the relevance condition to be violated. So the relevance, it is not relevant. So the effect, the trend, the path, the effect, the bias is transmitted is blocked because one channel is blocked. So that's the second part. And the third part, S12, it is the covariance between, where is it? Covariance between this and this, this and that. So this and this, for these two covariances to be, the covariance between these two guys to be 0, then it has to be 0. And Z2 and X1 and Z3 and X1 must be uncorrelated. So all of those are included in here. And you can tell what's going on. And here the sign is hard to tell because the denominator is more complicated. So 1 second. In this case, denominator is positive. It is always positive. So it's not a problem. So you can tell the sign of the bias by considering each of the three guys' bias. And the result here is, the lesson from this here is, using the more instruments is good for your accuracy, your estimation. However, it is dangerous because if you include more and more instruments, and if one of them is wrong, then everything is affected. Everything is biased. So if you are uncertain about including the new instrument, then don't do that. So you have to make sure all the instruments satisfy the exogeneity assumption. Otherwise, like small problem causes a big result. So that's the conclusion, and this is it. Okay, I will post homework number 2, and thank you for submitting your homework 1. I will try to grade them as soon as possible, but it may take time. So see you later. Bye.